I will first open a sample project attached to the program. In the top menu, select File, select Open. I point to the EC-Hall file and click Open. A structure model has appeared in the program workspace. This is a steel structure design. Beneath the top menu, there's a bar with buttons. These are for the most frequently used functions in the program. If the button icon is gray, it means that the option is disabled with the current settings of the program parameters. When I move the mouse cursor to the button icon, a hint about the command appears. To select a command, click the left mouse button on the button icon. I click on the View Change icons. The button next to which there's a triangular marker means that it is a drop-down menu. I click on the Expand mark and can see a list of available options. To select a command from the list, I move the mouse cursor over the command and click the left mouse button. I choose the command to insert a joint. By moving the mouse cursor to the program workspace, a hint will appear next to where the cursor is to indicate the starting point of the bar. We see that the execution of the command has begun. I click Escape and interrupt the execution of the command. We can see that the button icon has changed. Now the most recently used command is available directly from the toolbar. I will expand a few more buttons to show the available commands. I can change how the structure bars are displayed in the program workspace. In the upper right corner of the screen, we have a button to change the ways of displaying the bars of the structure. I click the left mouse button and display the available options. When I select the first option in the program workspace, I will see the actual cross-sections of the bars. When I select the second option in the work area of the program, I will see the actual cross-sections of the bars in transparent mode. I choose the third option from the drop-down list. The third option hides the actual cross-sections of the bars. We now see only the bar axis in the program workspace. I can also launch an additional 3D view window. From the toolbar, I click the Detailed 3D View button. In this view, I can also rotate the structure. I press the left mouse button and move the cursor. From this view, I can generate a report. I click the Report button. The report document started automatically. In this document, we have a picture of the current view and tables with data about the structure. I close the report. Now let's move on to the panel on the right. The panel contains 4 tabs: Geometry, Loads, Results, and Design and Verify. These tabs are arranged in a logical order. Using the function of the Geometry and Load tabs, we define the structure model. Switching between tabs is done by clicking the left mouse button on the tab name. First, we define the geometries of the structure. So I activate the Geometry tab. I click the left mouse button on the name of the Geometry tab. When I add a bar to the structure in the Geometry section, I can define, for example, the position of the starting point of the bar and the end point of the bar. I can select the bar in the work area of the program to see and change its cross-section. I can assign a bar to the appropriate group of bars. I press Escape to deselect the bar. I can select a node and define displacement locks and define rotation locks on the selected node. I press Escape and uncheck the node. I can define the connections between the nodes here. When we define the loads using the function of the Loads tab, after going to the Loads tab, we can see that the symbols of loads applied to the members of the structure are displayed in the working area. Before defining the loads acting on the structure, load groups must be created. I move the cursor to the load symbol. I will mark the load, click the left mouse button on the load symbol. The load has been selected. On the Loads tab, I can read the value of this load to which group the load belongs. By changing the value on the sliders in the Position section, I can specify the exact position of the load on the length of the bar. In the Direction section, I can change the direction of the load. I can also choose which load groups are currently displayed in the program workspace. When we click the left mouse button on the Results tab, static calculations will be started. After going to the Results tab, I can view the results of static calculations. First, we need to choose for which situation of load we want to display the results. For example, if we choose only the event of deadweight. Then we select the cross-sectional forces to show, for example, the bending moment My. In the workspace of the program, graphs appeared on the bars. On the bars, we can see a graph of the bending moment from the weight of the structure. Now, I will display the deformations of the structure from the dead weight. I mark the load group of the dead weight and mark Show Deformations diagram. In addition, I can turn on the deformations animation. I return to displaying a graph of the bending moment from the dead weight. I will select a bar in the workspace of the program. I'll go to the Results tab. I can read the values of the cross-sectional forces at any point of the bar. I indicate with the left mouse button the place where I currently want to read the values of the cross-sectional forces. I can also see the stress distribution at any point of the bar. I click on the button marked as stress. A stress window appeared in the cross-section. Here, I can see the distribution of normal shear and reduced shears and stresses in the cross-section. I close the window. The Design and Verify tab will be available when the results of static calculations are up to date for the calculation model. I click on the Design and Verify tab, and on the window that appears, I select the forces to be designed and verified for the structure. The program performs calculations according to the defined norm parameters. When the Design and Verify tab is active, we can view the results of the Design and Verify calculations of the elements: steel, wood, or reinforced concrete. On each bar, there is information about the degree of tension of the element under the norm conditions. I can view the results for the limit state of the load capacity and the limit state of usability. I can select the bar and click Generate Report. I can now view the exact report on the Design and Verify of the selected elements. I'll go back to the Geometry tab.